5.4, Day 2. We're solving radical equations and inequalities. When an equation contains a power with a rational exponent, you can solve the equation using a procedure similar to the one for solving radical equations. In this case, you first isolate the power and then raise each side of the equation to the reciprocal of the rational exponent. So here, example 5a, we have 2x all raised to the 3/4 plus 2 equals 10. So the first thing we want to do is isolate the power. So let's subtract 2. So we have 2x raised to the 3/4 equals 10 minus 2 is 8. So in order to get rid of that rational exponent, on the left side, we multiply by the reciprocal, right? So that's 4/3. So the 4's cancel, 3's cancel, that goes away. So now we're left with 2x equals, let's see, 8 to the 4/3. So remember, 3 is the index. So cubed root of 8 raised to the 4th power. So this becomes 2x equals cubed root of 8 is 2 to the 4th power. So 2x equals 16. And then divide by 2. So x equals 8. Of course, we should plug it in to see if it works out. So we should do a check. So check. So this is 2 times 8 raised to the 3/4 plus 2. Does that equal 10? So 8 times 2 is 16 to the 3/4 plus 2. Does that equal 10? And then, so this is 4th root of 16 cubed plus 2. So 4th root of 16 is 2 and then cubed. So this is 8 plus 2, and that equals 10. So that is true. So go ahead and try this one. Pause the video, and you try it on your own. Okay, so in this case, we raise it to the 4/3. 4/3. That cancels it out. So now we have x plus 2 equals, let's see, cubed root of 8 raised to the 4th power. It's very similar to the other one. X plus 2 equals cubed root of 8, 2 to the 4th. So x plus 2 equals 16 minus 2. So x equals 14. So let's check it. So this is 14 plus 2 raised to the 3/4. Does that equal 8? 14 plus 2. So 16 raised to the 3/4. Does it equal 8? So 4th root of 16 cubed. So that's 2 cubed. And 8 does equal 8. So x equals 14 is true. So same exact process, solving an equation with a rational exponent. So we have x plus 30 to the 1/2 equals x. So what we're going to do is we're going to square both sides to get rid of that exponent. So x plus 30 equals x squared. Now we have a quadratic, so we want to set it equal to 0. So we have 0 equals x squared minus x minus 30. And that's factorable. So this is x minus 6, x plus 5, or x equals 6, x equals negative 5. So we want to check the solution in the original equation. So let's clean that back up. So remember that x plus 30 to the 1/2. Another way to think about that is that's just the square root of x plus 30 equals x. And so you could always write it and solve it that way. It's the same exact thing. So let's solve. Let's try plugging in 6 to see what happens. So 6 plus 30 square root, does that equal 6? So square root of 36, does that equal 6? Yes, 6 equals 6. So x equals 6 works. Then we plug in the next one is negative 5. So square root of negative 5 plus 30 equals negative 5. And actually, in this case, you probably already know that's not going to happen with an even index, because this is the square root of 25. Is that going to equal negative 5? Well, square root of 25 is 5, and that certainly does not equal negative 5. So the only one that works is x equals 6. So go ahead and try these two, and then I will do the examples or work out the examples in the next video.